Welcome to the Math Record. Today we'll be covering the CCML Geometry Contest for 2015-2016 Division A. Okay, question 1. An isosceles right triangle has a length of leg of length 5. Compute the length of its hypotenuse. So since it's an isosceles right triangle, basically what it's telling us is that this is a right triangle, and you have a 45 degrees and another 45 degrees, basically. So since they have a leg of length 5, there's also a length of like 5. So if you kind of know your 45, 45, 90 triangle, you know this 5 square root 2. But you can also just use the Pythagorean theorem, which is just 5 squared plus 5 squared square root to get the hypotenuse, which is just 25 plus 25, which is 50. And square root 50 is just basically 25 times square root 25 times square root 2, which is just 5 square root 2. The answer is just 5 square root 2. It's basically just that simple. Okay, question 2. A circle C has diameter on the x-axis, has a diameter on the x-axis, and an area of 11. If the circle is translated 13 units in the y direction and then reflected over the line y is equal to x, what's the area of the resulting shape? Just because like you moved the area to a different place and then like kind of switch where it is, basically the area is not going to change. So the area is just going to stay 11. The only way you change the area if you like multiply like some of the coordinates. So compute a cosine of 60. If you know your 60 degrees, your 30, 60, 90 triangle, it's basically just 30 and 60 and let's say this x, right? Your hypotenuse x. Then the opposite of the 30 is x over 2, and the opposite of 60 is x squared root 3 over 2. So cosine of 60, which is this one, is just x over 2 divided by x, which is just 1/2. So the answer, so for number 3, the answer is just 1/2. You should just know the 30, 60, and 90. It's the most commonly used, aside from the 45, 45, 90. You're standing on the coordinate plane at 2, 5, and just for fun, you decide to rotate yourself around the origin by 1,800 degrees counterclockwise. After your dizzy trip, how far are you from the starting position? So we need to know how much like times you're rotating around, because 360 is you just went a whole circle. So technically 360, and what amount goes that is less than or equal to 1,800. So if x is equal to 5, that's 1,500 plus 30, so that's 1,800. So you basically just made a circle 5 times. So you're basically at how far are you away from your starting position? You're basically just 0 away, because you just went the circle around 5 times. So you went 1, then 2, then 3, then 4, then 5. I'm not trying to overlap so you understand like how much you're just going around. The answer is just 0. Because you're back at the starting position after 180 degrees counterclockwise. A road has an angle of elevation of 30. Sorry. A road has an angle of elevation of 30 degrees. If you travel 1 horizontal mile on this road, how many miles has your elevation changed? So, as I said, you basically just use the 30, 60 degree triangle. So you have an angle elevation of 30 and the 60, and it says that you travel 1 horizontally. So basically, if like here's so it's x over 2 and x squared root 3 divided by 2. So for the 30 degrees, they said you travel 1. So how many your elevation changed? So how much do you go up, basically? So you basically have x over 2 divided by x squared root 3 over 2. So 1/2 divided by square root 3 over 2, which is just equal to 1 over square root 3, is equal to whatever this amount is. We'll just call it I don't know, a. And then we have is basically just a over 1. So 1 equals square root 3 over a. So basically we just need to find whatever this is. So it's just multiply square root 3 by the top and the bottom, because it's just multiplied by 1 technically, so it's just square root 3 over 3. So that's your answer, square root 3 over 3 miles. Okay. Question 6. A sphere A has a radius dilated by a factor of 9 to create sphere B. What is the ratio of sphere's surface area to the What's the ratio of the sphere's B surface area to sphere's A surface area? So it's gonna be less than 1 because actually it's not gonna be less than 1. It's gonna be greater than 1 because since it's dilated by a factor of 9, so B is bigger than A. So basically the area for the formula to get a surface area of a sphere is 4 pi radius squared. So the radius squared tells me it's a second dimension. So let's just say the radius of A is 1, right? So if the radius of A is 1, then basically the surface area is 4 pi. And if it's dilated by a factor of 9 to make B, that means sphere B's radius is 9. So it's 4 times 9 squared divided by pi. And so the ratio of B to A is just 4 9 squared of pi over 4 pi, which is just 9 squared, which is just 81. So your answer is just 81. Like, you also do this with variables, but if you plug in a point, it should also work, because this is a general case. Number 7. Given a circle with radius 5, center at the origin, what's the slope of the line that is tangent to the circle at 3, 4? So let's kind of draw a picture. We have a coordinate plane, and we have a circle at the center, and its radius 5. And there's the point that's tangent at 3, 4. So you have a point right here, right? And this tangent to it. Oh, sorry. Then you have a point, line tangent. So what it a tangent line will always be 90 degrees to that circle. So what this tells me is that this is a perpendicular line. So since the point is 3, 4, so this is 3, 4, right? So that's 3, 4. Basically, the slope of this line is 4 over 3. So the perpendicular slope will be the opposite in the reciprocal, so it's negative 3/4. So the slope of the line that's tangent to the circle is just negative 3/4. Basically, just that simple. Number 8. A triangle has a side lengths x5 and 6. Let A be the minimum value and B be the maximum value, such that B less than A. I mean, B is less than x, which is less than A, is true. So for it to be a triangle, technically 2 of the side lengths added together has to be greater than the last side length. So let's say x is less than 5 and 6, or x is between 5 and 6, and x is greater than 5 or 6. So x plus 5 has to be greater than 6. So greater than 6, right? So x just has to be greater than 1. So for this one, is x has to be greater than 1. So since these are the two smallest ones, it's basically the same case. 5 plus x is greater than 5, so x would be greater than 1. 5 plus 6, which is 11, has to be greater than x. So x has to be less than 1, has to be greater than 1, has to be less than 11. So compute a and b, which is just 1 and 11. So that's just 12. Pretty simple. Number 9. Determine the area of a quadrilateral with the following vertices in cyclic order: 3, 3, 7, 0, 3, negative 10, and negative 1, 0. So what I'm going to do is I'm going to use the Shoeless Theorem. This is discussed in like previous videos where you basically just get the area of a shape in the plane using their coordinates in a matrix. So it just gets the area of a polygon basically. So a quadrilateral would be like that polygon. So we have 3, 3. Always draw a picture first. Then 7, 0. Actually, 3, 3. Like right here. 7, 0. You don't have to be very precise. You could just do a rough idea, because I just want to get the general picture. And then you have 3, negative 10. And you have negative 1, 0. Oh, okay, never mind. So we don't have to use the shoelace theorem for this one. This one's actually really basic. So you could use the shoelace theorem. So basically what you're gonna do is that you gotta use the rightmost point. So you have this, which is just 7, 0. And then you could use the next point counterclockwise. So going counterclockwise, you have 3, 3, and then negative 1, 0, and then you have 3, negative 10. and then you go back to the first point, which is 7, 0. And you basically use each one for a matrix. So 7 times 3 is 21, minus 0, so 3 times 0, 0. So 3 times 0, 0, minus negative 3, so that's plus 3. And negative 1 times negative 10 is 10. 3 times 0, 0, so minus 0. 3 times 0, 0, and 7 times negative 10 is negative 70, so minus negative 70 is plus 70. So these don't have anything because they're basically just zeros. So you basically have 21 plus 3 plus 10 plus 70, which is 80. 80, 104. So 104 times 1/2 is basically 52. The answer for number 9 is just 52. Or you just use the easier way, which basically, since this is basically just kind of like a triangle here and then a triangle here, you kind of could, I mean, it's basically kind of just like a quadrilateral. It's just base times the height divided by half. Because think about it, you could just draw a rectangle, right? And basically this area would be the same as this area, this one was the same as this is the same as this is the same as this. So you multiply by the base and height, you get the area of the rectangle. Then you divide by 2 because each of the areas is kind of the same. Then you just get the area of that like quadrilateral. So the distance between this is negative 1 and this is 7, so that's 8. And the height is from 3 to negative 10, so that's 13. So then 8 times 3, which is the area of the rectangle, divided by 2 is getting the area of this of the quadrilateral, which is just 52. So that's another way to do it. Number 10. Trapezoid MEOW has base ME and OW. Okay? With length 5 and 10 respectively. So let's kind of draw this out. You have MEOW. So yeah, 5 and 10. And it has a height of 4. 4. Rotating MEOW 180 degrees, so it's going to go 180 degrees, around the midpoint of EO, right here, EO, results in figure MEOW. So if you kind of rotate this 180 degrees around this point, technically you're just moving this shape over here. So you're kind of drawing this. So you have M, which will go over here. So, and then W will go 180 is over here. So this is just, and then basically this point will just move over here, that's E, and then O, would just go up way on top, so it would be O right here. So the MEOW, so it looks like that. So you kind of get the general idea how it looks, right? So, results at MEOW prime, so they just add the prime, so that's basically the new figure, it doesn't really mean anything. Compute the, actually, let's just write that out. So we have M, so this is M prime, and doesn't matter what that is. So that's moved over there, so this is W prime. And this is E prime, and this is O prime, which is at the same point as E and O, so respectively. Compute the area of M prime, W prime, M and W. So basically, since this is 10, this will also be 10 because you're just moving 180, and this is 5. So the area of this, if you kind of just move this shape over here, right, it's basically the area of a rectangle. So technically, we just have base. So we have this entire thing is 10. So that so it's just length times height. So it's just 10 to, plus 5, which is 15 times 4. So the area is just 60. So 10 is just 60. Basically that simple. It goes a long way to always just make a picture. Number 11, compute the distance between the lines determined by y is equal to x and y is equal to x minus 1 and y is x plus 1. So you have a picture, you have a line like this and a line like this. You just have to find the distance. So what you do is that you basically find the perpendicular line. So if this is perpendicular and perpendicular, you get this point and you get this point, and then you just find the distance, and that's the distance between the line. So let's just use the simplest perpendicular one of y. So a perpendicular slope has just be the opposite and the reciprocal of the slope. So the opposite and the reciprocal of the slope is just negative x and negative 1 because that's 1. So the opposite of 1 is negative 1. Reciprocal of negative 1 is just negative 1. So this is the simplest one. You could add a b if you want, but you don't have to. So if we do something like this, we have a picture. and we have a slope that goes through the origin that's negative x. So that's how it looks. So now we just have to find these 2 points. So we have negative x is equal to x minus 1. So that's 2x is equal to 1 half. 2x is equal to 1, so x is equal to 1 half. So those points intersect at 1 half, negative 1 half. And now we have negative x equal to x plus 1. So this 2x is equal to negative 1, so x equals to negative 1 half. Okay? So we have negative 1 half. Plugging it back in, you get 1 half. So negative 1 half plus 1, 1 half. Okay, so these are the 2 points. So the distance between 2 points, basically using the form, it's just 1 point minus each coordinate minus the other coordinate squared. So it's just 1 half minus 1 half. Negative 1 half minus 1 half is negative 1, so negative 1 squared. 1 half minus negative 1 half is just add a negative and negative positive, so it's just 1. This is plus 1 squared. Square root, so 1 plus 1 is just 2. So it's x. So the distance between the 2 lines is square root 2. Okay. Question 12. Using the awesome identity, a sine of a plus b is equal to sine of a times cosine of b plus cosine of a times sine of b. Can you write the exact value of sine of 75 in the form square root a b plus square root c over d, where a, b, c, and d are positive integers? Compute the minimum value of a, b, c, d. So we're given this identity. So what values can we a and b can we put together to make 75? Well, you only know 2 triangles if you know your unit circle, which is the 30, 60, 90, and the 45, 45, 90. So these are the 2 angles you're gonna use, the 30 and the 45, which adds up to 75 perfectly. So we have sine of 75, which basically just sine of 30 times cosine of 45 plus cosine of 30 times sine of 45. Sine of 30, if you know your triangle, which is, like as said before in question 3, you have 30, 60, and then if this is x over 2, and this x square root 3 over 2. 45, 45, 45, 90. If this is x, then this would be x square root 2 over 2, and this would be x square root 2 over 2, basically. So, yeah. So now we just have to find sine of 30. Sine of 30 is 1 half. Cosine of 45 is square root 2 over 2. So times square root 2 over 2. Plus cosine of 30, which is square root 3 over 2. And sine of 45, which is square root 2 over 2. So let's kind of erase part of this so we get a little bit more room. Okay. So we have multiplying that together, that's square root 2 over 4 plus square root 6 all over 4. So we can put them together, so that's square root 2 plus square root 6 over 4. You could scribble out the square root 2 away, so you get 1 plus square root 3 over 4. So a would be equal to 2, b would equal to 1, c would equal to 3, and d would equal to 4. So a, b, c, d is just 1 plus 2 plus 3 plus 4, which is equal to 10. So the answer for 12 would just be 10. Question 13. Determine the area of a pentagon with the following vertices in cyclic order. This one you probably want to use the Shoeless Theorem. So you have 1, 1 right here. You have 9, 1. Oops. Sorry, it's right here. 9, 1. So let's draw a little bit right here. 10, 5. Oops. Here. Right here. And 8, 3. So somewhere here. And 1, 4. Right here. Okay. You kind of want to connect them all together. Get this shape right here, basically. So that's our pentagon. So to get the area, we're just gonna put them in order. So the rightmost point is right here, which is 10, 5. Let me kind of delete this. Oops. Okay. So we have 10, 5. And then going counterclockwise, we have this point, which is just 8, 3. And then we have 1, 4. Then we have 1, 1. And then we have 9, 1, 9, 1. And then you write back the original point, which is just 10, 5. The first point. So to get the area, you basically just use matrices like these 2 points, then these 2, then these 2, then these 2, then these 2. So 10 times 3 is 30. 8 times 5 is 40, so you minus 40. That's 32 minus 3. That's 1 minus 4. And this is 1 minus 9. And that is 45 minus 10. So you kind of just want to like take out numbers that you already could take out. So the minus 40 could take out from the 45 to get 5. The minus 10 could take away from the 30 to make 20. The negative 3 and the negative 9 together makes negative 12, which you take out from the 32 to make 20. And that's negative 4, so take out the 1s to make this negative 2. So you have 20 plus 20 plus 5 minus 2, which is just 43. And the area of basically a whatever is remaining, just multiply by 1/2 and you get the area. So the area is just 43 over 2. So for number 13, the answer is 43 over 2. Okay. Number 14. Point P has coordinates 4, 3. P is reflected over the x-axis to view P prime. Okay, let's actually just start working with this already. So we have 4, 3 right here. 4, 3. And it's reflected over the x-axis, so it's going over here. So we're gonna have right here. So if this is 4, 3, right, then this is 4, negative 3. So you get P prime. And then P prime is reflected over the equation y is equal to negative 2x. So it's over here. To get P double prime. So we're gonna have to move this point right here, basically. So we're gonna make a perpendicular line. So it's gotta go perpendicular right here. And then you find that point right here. Whatever the distance here, you just do the exact same thing again, so you get the other point. So a perpendicular line that goes through that perpendicular line to y is equal to negative 2x that goes through 4 and negative 3. So basically, we're gonna have y is equal opposite and reciprocal of negative 2 is just 1/2 x. That goes through 4 and negative 3 that makes 2, so that's minus 5. Right? So now we just need to find out when they intersect. So 1/2 x minus 5 is equal to negative 2x. So adding that, so that's 4. That's 4 over 2, so that's 5 over 2. X is equal to 5. So x is equal to 2. So if x is equal to 2, then y is equal to negative 4. So this point right here is 2, negative 4. And now you just have to find that other point right here. So basically, from 4 to 2, you're going to minus 2. So then 2 minus 2 is 0. So it's going to be on the y-axis, basically. And then negative 3, you got to minus 1 to get to negative 4. So negative 4, you got to minus 1, you got to get negative 5. So so number 14 is just 0, negative 5. Okay. Number 15. Determine the coordinates of the center of a circle that passes through negative 4, 0. Let's kind of draw this out. So we have negative 4, 0. negative 4, 4, and 3, 3. Okay. So we have a circle that goes through all these points. A way that I kind of always do about the way that I kind of wait, what's this? Number 15, according to the center, is the way that you basically do this is that you basically find the perpendicular bisector of two lines. So you find the perpendicular bisector right here, and of this line, and perpendicular bisector of this line. So it's 90, 90, and this is basically the same length. Sorry. And then you have the same length right here, basically. Then these points intersect right here, right? And that point is the basically the radius. I mean the center of the circle. Because think about it, because if you have this thing is the same and this is perpendicular, right? Then this has to be the same radius as this. And if you have the perpendicular right here and and they're basically the same and this is the height, then basically this has to be the same radius as this, right? So all three of these have to be same radius, so it goes through every single point. So that's how you think about it. So let's just we're just gonna use this idea. So we have points 3, 3 right here, and you have negative 4, 0, and you have negative 4, 4. So the perpendicular line for this, we need to find the midpoint because it's a perpendicular bisector. So that's add them together. So that's negative 1, negative 1 half. So the point is negative 1 half, and then 3 over 2. So the slope is 3 minus 0, which is 3. 3 minus negative 4 is 7. So the slope of this is wait, sorry. I don't know why I wrote 4, 0 again. 4, negative 4. Okay. So that is negative 1 half and 7 over 2. Okay, that's the midpoint of this point right here. Now we just need to find the slope. So 4 minus 3 is 1, and negative 4 minus 3 is negative 7. So the slope of this line is negative 1/7, and the perpendicular slope would just be opposite and reciprocal, so it's just be 7. So this one is y equals 7x, and has to go through negative 1 half 7 over 2, so that's negative 7 over 2. So this is plus 7, because this is negative 7 over 2, so this would be the same thing as 14 over 2, that's 7 over 2. So this is the equation of this line. Now we just need to find the equation of this line. So this line is basically just the midpoint is just negative 4, 2. I mean, negative 4 plus negative 4 divided by 2 is just negative 4. 4 plus 0 is 4 divided by 2 is 2. And then basically since this line is like undefined, this is just like vertical and it's going straight down, that means this slope is just basically 0. So the line just has to go through this value, which is the y value, which is just y is equal to 2. So we already know that the slope, the center is at 2. Now just plug in 2 for y here. 7 minus 2 minus 7 is negative 5, and negative 5 divided by 7 is negative 5 over 7. So basically, the center of the circle for 15 is negative 5 over. Sorry if that doesn't. Negative 5 over 7. Okay, let me just rewrite this. Negative 5 over 7, 2. And that's basically how you do it. If you have 3 points, just look for perpendicular bisectors. You could do it for the third one if you want, but you're just going to be wasting time, and you only need 2 lines. Question 16. Circle C has radius of 1 and a center at 1, 0, and circle C is rotated 90 degrees counterclockwise around the origin to create circle D. If R is the region that's formed by the union of the interiors of C and D, compute the area of R. So, gonna have a circle, center right here, 1, 0. So when it's rotated 90 degrees, it kind of gets up here. Okay. So, I'm guessing that if it's the intersection is right here, because it's at 1, 1. So this would be a 1, 1, 1, 1 square, basically. And you have the area of this. Because you want to find the area of the union of this. So you want to find the area of this. So basically you want to find the area of this circle, the area of this circle, minus the intersection. So you get the area of the union, basically. So that's what it's telling me. So we need to find the area of both the circles, and then subtract the area of the intersection. So we just need to find the area of the intersection, basically. Because the area of the circle is already, since they're both radius 1, even if you like rotate it, it's still going to be the same area. So the area is pi radius squared, and the radius is 1, so the area is pi here and it's pi here. So both these is 2 pi, adding them together, and now you just need to subtract this intersection out. So, we gotta check like where the intersection is probably gonna be. So if we have the circle which is at 1, 0, so x minus 1 squared plus y squared is equal to radius 1. And since it's rotated like 90 degrees counterclockwise, it's gonna be right here. So it's gonna be centered at 0, 1. So you have x squared plus x y minus 1 squared equals radius 1. So if you multiply the first equation by -1, and then you add it to the second equation, you're gonna get that's negative 2x. So that's just 2x. And then plus 1, that's minus 1. That's negative y, so that cancels there, and then -1 cancels right there. So from here, you get left over with negative 2y plus 1 is equal to 0, basically. So this is when you add them to multiply the first equation by -1 and add the second one. So you basically get 2x is equal to 2y, so x is equal to y. So basically they're saying x is equal to y. So substituting that back into one of our equations, let's say our y here is equal to x, so x minus 1 squared plus x squared is equal to 1, so that's 2x squared minus 2x, that's plus 1, minus the 1 here is equal to 0. So distribute out the 2x to get x minus 1. So they intersect at 0, 0, which is pretty obvious. And you have a picture right here. Oops. Here. So they obviously intersect at 0, 0, and they intersect at 1, 1. So at 1, 1. Because if you plug in, this is, so if x has to be 1 here and 0 here. So 0 is 0, 0, and 1 here, you put 1 in here. 0 squared plus y has to be 1, so it has to be 1, 1. So it's going to be at 1, 1. So it's proven that it's going to be at 1, 1. So if we kind of draw the diagram out again, we have a circle here, and we have a circle right here. Okay. So this point is 1, 1. So that tells me that so that means the center is right here and the center is right here. That means they make us a perpendicular line. Because this is at 1, 0, and this is at 0, 1. So this makes a square, a 1 by 1 square. So, and it goes through the center. So basically this is a really common idea where you just have a square, and then you put a fourth of a circle, and then you basically just get the area from this one and the area of the square. So then when you subtract them together, you get this area. And then you do the same thing for this side, so you get this area. Because they're basically the same area. And then when you put them together, you have this area and this area. And then you subtract those areas from the square and you just get this area. So that's basically what we're going to do. So, and since the area of this circle is pi radius squared, which is just radius 1, so the area is just pi. Since it's a fourth of the circle, it's going to be pi over 4. And the area square of a 1 by 1 square is just 1, so it's just 1 minus pi over 4, which is equal to this area. So I'll multiply by 2 so you could get both of those areas. So this area and this area. So that gets 2 minus pi over 2. Since you want the area of this, is you just have 1 minus this entire area. So 1 minus 2 minus pi over 2. It's basically just -1 plus pi over 2. So that's the area of this. Since our area of this circle D and circle C added together was, as we said before, was 2 pi. We just need to subtract out this amount, basically, because that's the intersection, as I said before. So subtracting that amount, you get 2 pi minus pi over 2, which is just 3 pi over 2. Minus a negative 1 is just plus a 1. So the union of the two circles is 3 pi over 2 plus 1. Okay? Uh problem 17 to 18 in the diagram to the right. The circle centered at O and EF and EC are tangent to the circle, okay? So if CEF if the angle is 110, determine C O wait, no, if CEF is 110, determine COF. Okay? So basically this is just an inscribed circle, so kind of ignore all the lines except that. So basically this is 110. Let's call this arc over here x. So this entire arc out here, since they had to add to 360, is 360 minus x. So 360 minus x plus x is 360. So inscribed angles tells us that this arc minus this arc is divided by 2 is equal to 110. So 360 minus x minus this x is minus 2x together, and half of that is equal to 110. So multiply 2 to the other side, that's 220. 360 minus 220 is 140 is equal to 2x. So x is equal to 70. So since this is 70 degrees and you have a point right here, that means this is also 70. So basically 17's answer is just 70. Basically that simple. Number 18, AOF is 120 degrees. OA is 1, and BO and E are collinear. 5. Compute GC. So G and C. So we need to find this. So basically, if AOE is 120 degrees and OA is 1, and that point is collinear, that means, okay, so we have a draw a line, and we have a point here, and a point outside. So since they're collinear, that means they're on the same line, and it goes through this point, and then basically it does the exact same thing here. Since these are collinear, right, that means C right here also has, this shape is exactly the same as this shape. That's what it's telling us, basically. So GC is the same thing as AF. When they say BOE is the same thing as, since they say BOE is collinear, that tells me that A and F is basically the same as GC. So this line over here is the same as this line over here. So that tells me that if this is 120 degrees, then this is 120 degrees. So from that information, we could get the idea right here is 120 degrees. Since they said that OA is 1 and O is the circle and A is the point of the circle, that means it's just radius 1, basically. So compute GC, we just had to find this. So let's kind of just draw this out. Split that in half, so it's the 120 is 60 and 60. So it's 1. If you kind of know your 30-60 triangle rule, so you have a 60 and 30. If this is x, this is x square root 3 over 2, and this is x over 2. So that's the length measurement. So since this is 30 and this is 1, it's just 1 times square root 3 over 2. So this would just be square root 3 over 2. This 1 times square root 3 over 2 is just square root 3 over 2. Since there's 2 of them, you have these two, and add them together, you just get square root 3. So your answer for number 18 is just square root 3. Question 19. One face of a regular tetrahedron has an area of 4 square root 3. The distance from one vertices of the tetrahedron to the incenter of the opposite face can be written in the form a square root b divided by c, where a, b, c are positive integers. Give the minimum value of a plus b plus c. So, okay. A tetrahedron is basically made by 4 equilateral triangles. So, it's like this. and it's kind of hard to draw a DD, but basically it's like that ish. Now, let's just make it in 2D right now. So we have an equilateral triangle, and one face have an area of 4 square root 3. The area of an equilateral triangle is just x squared square root 3 divided by 4. So it's equal to 4 square root 3. So that's 16, so x is equal to 4. So x is the side length, so the side length of the equilateral triangle is 4. That's what it tells us from the area of 4 square root 3 of a regular tetrahedron, of one face. In center is basically the point that's made by like 3 lines together that intersect that one point. Is what when the and in center is the lines that are like perpendicular bisectors from the vertices. So these two are the same angles. These two are the same angles, and these two are the same angles. So made by 3 perpendicular bisectors, and I mean made by 3 angle bisectors, and it makes the incenter. So based on that, if we kind of draw this 3D, so we have a point right here, right? And it says from the distance from one vertex, so let's say this vertex, the opposite face, so the incenter right here, basically, you're gonna have to find that distance. So basically use this triangle right here, and use that like line. So we're gonna use the height from here of this face of this triangle, and we're gonna make a line to here, and then make it perpendicular, basically. So we just need to find that perpendicular height, and that's the distance between them. And now we just need to find the height of this face. Since all these are equilateral triangles, right? Every single thing is like a tetrahedron, so it's a regular tetrahedron. Then basically we just need to find the height of this. So if that is 4, then half of this, since it's height, this is 2. So 2 squared plus, let's say this height squared, is equal to 4 squared. That's 16 minus 4 is 12. So h is equal to square root 12, which is just 2 square root 3. So the height is 2 square root 3. So that's our hypotenuse in this case, because we're using this triangle. And now we just need to find the length of this. So the length of this is basically if you use a triangle again, right? We have a equilateral triangle, and we need to find that point. So we're looking for this line over here, this length. So basically, there's a really cool property about this, which states if it's an equilateral triangle, the incenter, the and the circumcenter are basically the same point. So a circumcenter basically tells us that from the vertice to that point, and from that point to the intersection that the line is made with the side, the ratio is 2 to 1. That's what it's telling us. So using that, since this is basically the same height, which is just 2 square root 3, then basically we just need to find this length, which is just 1. It's just 1 out of the entire thing, which is 1/3. So it's just 1/3. So 1 plus 2 is 3. So this length is basically just 2 square root 3 over 3. You basically just need to know your properties for like these regular shapes, like incenter and circumcenter. Like the ones that you need to know, incenter, circumcenter, orthocenter, and centroid. The most important is probably like centroid, which is made by 3 medians. If you want to search these up, they're just basically special points in a triangle. There probably is more, but you really don't need to. You only need to know those 4: orthocenter, circumcenter, incenter, and centroid. Now you have 2 square root 3 right here. Now you basically just use the Pythagorean theorem, since it's a right triangle, to get it. So you have right here, triangle, and you have 2 square root 3, which is this line right here, and this line over here is right here, which is 2 square root 3 divided by 3. And we'll call this h. So we just need to find h. So basically we have 2 square root 3 squared plus h squared is equal to 2 square root 3 squared. So let's move this up. sorry. Okay. And now we have basically that's 4, that's 3, and that's 9. So this is just 4/3 plus h squared. That's 4 and that's 12. So actually, let's move this a little bit up. 4/3 plus h squared is equal to 12. So h squared is equal to, that's 36 over 3. This is the same thing as 36 over 3. So this is 32 over 3, subtracting it out. So h would be the same thing as 4 square root, that's 16 over 2 over square root 3. Which is the same thing as 4 multiplied by square root 3 from the top and the bottom. So you get 4 square root 6 all over 3. So that's our a square root b over c. So adding them together, 4 plus 6 plus 3, that's 13. So the answer is just 13. Question 20. In the diagram at the right, the circle with center A passes through B. The circle with center B passes through A. Point C is on arc EAD. Okay, and it's collinear with F and E. Determine the measure of CDF. So it would kind of draw two circles. Since they intersect at the same center, that means they have the same radius. So that tells me if we make a triangle right here, that's radius r, right? And based on this circle, this is also radius r. And based on this circle, this is also radius r. So this is equilateral. So this is 60 degrees. That's what it's telling me. Using that concept, this is also 60 degrees. So that they're telling me is that this arc and this arc is 120. So since the entire circle is 360, that means this must be 240. So using the idea, let's draw that line right here and right here. So basically, since this is 240, right? And this is an inscribed angle. So basically what this tells me is that the inscribed angle is just half of that arc. So arc DE, half of that is 240 is 120. So since this is 120, that means this is 60. So since this is 60 degrees, this tells me that triangle FCD is equilateral. Since this triangle is equilateral, that means because think about it, because if F and D are basically like a circle, you make another circle with C as the center, and that's 60, right? And you kind of just draw a line. It's just gotta be equilateral. So that's the point. So if since CF and D is equilateral, that means angle CDF is also just 60 degrees. That covers everything for the CCML Geometry Contest for 2015-2016 Division A. Thanks for watching, and I'll see you at the next math record.